module, you should be able to describe the Junos OS and its basic design architecture. Junos OS is a trusted and secure network operating system. Junos OS powers the high-performance network devices offered by Juniper Networks, such as routers, switches, and firewalls. Junos OS, depending on the device, runs on a modified and hardened version of either FreeBSD or Linux. Having Junos OS running on all network devices gives administrators the ability to have one operating system network-wide, and thereby dramatically reducing the complexity of network management. The Junos OS is divided into multiple software processes. Each process handles a portion of the device's functionality. Each process runs in its own protected memory space, ensuring that one process cannot directly interfere with another. When a single process fails, the entire system does not necessarily fail. This modularity also ensures that new features can be added with less likelihood of breaking current functionality. The Junos High Availability, or HA features, makes the insertion of device line cards and network OS upgrades a non-service impact event. Junos OS enables meaningful device configurations by providing an intuitive configuration hierarchy and including the ability to annotate the configuration. Configuration management is also made easier with the ability to perform syntax checking before committing the configuration, and when needed, enabling configuration rollbacks after the configuration has been committed. Junos OS supports fine-grained network traffic controls, while separate control and data planes increase reliability and security. Over time, Junos OS has evolved from a monolithic operating system to a disaggregated network operating system, where the Junos OS has become independent of the hardware, and the operating system itself has been separated into its individual parts. This disaggregation enables a more flexible licensing consumption model for network applications and enables a DevOps approach that simplifies complex network operations and improves service agility. Junos OS has always included automation and now includes a wide range of automation capabilities using representational state transfer, or REST, Network Configuration Protocol, or NetConf, SONiC, and gRPC APIs. Note that for in-depth coverage of Junos OS, refer to the Juniper documentation website. You can access the website from the reference links document. As mentioned earlier, with Junos OS, it is possible for all devices network-wide to run one operating system, Junos OS. All platforms running Junos OS use the same source code base within their platform-specific images. This design ensures that core features work in a consistent manner across all platforms running Junos OS. Because many features and services are configured and managed the same way, the setup tasks and ongoing maintenance and operation within your network are simplified. Juniper Networks releases a new version of Junos OS typically each quarter of the year. Junos OS releases are numbered using the form M.NZB.S, where M.N are the main and minor release numbers that give the Junos OS version. For example, 21.1, which indicates the first quarter of the year 2021. The Z denotes the release type, B is the build number of the product, and S is the spin number of the product. The most common type of release is the R release type. The R1 release is the first revenue ship or FRS release. The R2, R3, and following releases are maintenance releases. New R releases such as R2 and R3 include bug fixes only. That is to say, version 20.3R2 does not contain any features not included in 20.3R1. New features are not introduced until version 20.4R1. When you upgrade a Juniper device running the Junos OS, the Junos OS software upgrade packages also follow the naming convention just described. Although individual architecture modules of Junos OS communicate through well-defined interfaces, each module runs in its own protected memory space, preventing one module from disrupting another. It also enables the independent restart of each module whenever required. This is in contrast to monolithic operating systems, in which a malfunction in one module can ripple to other modules, possibly causing a full system crash or restart. This modular Junos OS architecture provides a high level of performance, availability, security, and device scalability not found in other operating systems. The example shows some of the common software processes running inside Junos OS, which can be verified with the Show System Processes extensive CLI command. For a brief overview of the main Junos OS processes, refer to the document provided in the results